Good morning, sir or miss. My name is Kamin Yi, and I'm from Group 4. We're working on a smart home system, and it's about smart consumable monitoring. This is our architecture diagram. Our system consists of two modules. The first one is the inventory checking module, and the second one is the expiry detection. The inventory checking module focuses on home supplies that needs frequent restock, such as detergent, toilet paper, and another module, the expiry detection, focuses more on the refrigerator. It captures images and takes note on the expiry date of the food. If the food is going to expire, it will notify the users about it. Now I'll be talking more on the inventory checking module. First, we'll be looking at the IoT core. We have configured rules in IoT core. What this rule does is whenever the sensor sends a message, when it publishes a message to this topic called the toilet paper thickness topic, one action will be triggered, which is the message will be sent to a S3 bucket. And the name of the S3 bucket is the IoT core S3. This is the role. The bucket name is IoT core data. Okay? We'll go to the MQTT test client to test it out. First, we need to key in the right topic. So click on publish the topic, key in the right topic name, and we assume that this message is published by the sensor. The sensor is in the master room toilet, the timestamp, and now it detects the toilet paper is 13 millimeters left. Okay, click on publish, and the action will be triggered. When we come to this IoT core data S3 bucket, we see it is updated. We can download this file and check out what's inside. It's actually the message that we just published. Okay, so it's exactly the same thing. Now, we'll take a look at the next service, which is the Lambda. So what this Lambda does is it converts the MQTT message to CSV. Okay, we will take a look at the code here. So what it does is, it is linked to a bucket. The trigger is the IoT core data. And when it detects that there's a new object upload, it will trigger some action, and the destination bucket is the DCS IoT data bucket. So what it does is it creates a CSV file and store it inside the destination bucket. Okay, so the trigger for this function is the IoT core data. Based on the code, it will store the data into DCS IoT data S3 bucket, and the file name is thickness.csv. This action will trigger another Lambda, and when there's a new upload into this bucket, what it does is it'll trigger the forecast, is ARN. Okay, let's take a look at the forecast. We have already created a forecast here. We already have a predictor, and what it does is it will query forecast. This is how we do it manually, but now we're doing it programmatically using the Lambda here. And then eventually it will create a CSV file and store the prediction inside the CSV file and into an S3 bucket called the forecast bucket DCS. Now let's take a look into this S3 bucket. This newly created CSV file is the result of the forecast. It predicts that by the 14th of January, toilet paper left is 10 millimeters, 0.9, and 15th of January, only 8.9 millimeters of toilet paper will be left. And when it is lower than a certain threshold, the system will notify the user.
Okay, so in step 3, we have successfully created a forecast and carry out the forecast value. So if the forecast value is lower than a threshold we have set, we will need to send an email notification to the user to notify the user about their consumables is running out. So to send an email notification to the user, we will be using AWS Simple Notification Service SNS to notify the user via the email. Okay, so to use the AWS SNS, first we need to create a topic first, like here. I'll show you. Okay, this is the AWS SNS dashboard. So we click on the topics to create a new topic to let the user to subscribe to, and then we will add the subscription to the topic we have created by clicking this create subscription. So these are the subscription that has been subscribed to different topics. So let's get back to the manual. So after the user has subscribed to the topic, this is a Lambda function to send the message to the user. So any user that has been subscribed to the topic will receive the notification if the consumables is running out or the forecast value is below a certain threshold. As shown in here, this is the threshold value we have set for the toilet paper thickness. Next, we will be finding a nearby convenience store for the user to replenish the running out consumables. So we will be using the Amazon location service to realize. So we will be using Amazon location service to achieve this goal. I'll show you here. So this is the dashboard for Amazon location service. So this is the place index. So we can search places in our interested area. For example, we type stores, and then the Amazon location service will show all the nearby stores on the map. So when we scroll down, this will be the API to request for the place index, and this is the sample response of the nearby stores. So we can use this API request and the place index in AWS location service to search for the nearby stores for the users to replenish on their running out consumables.
My name is Tam Hui. Now, ID number is 1902060. So now I'm gonna start my presentations. This is the rotten fruits recognition modules. So the S3 buckets, after I upload some things into S3 buckets, the bucket will start to trigger the Lambda function about this and start processing the image about it. And after finish processing, the result will be then sent to the Amazon SNS to alert the user. So here is the coding about the functions. So first initialize the clients, the recognitions, DynamoDBs, and SNS. Next is the function about the recognitions here. This, after the image, we'll start to identify the label about the image, and then this the functions about extracting the interest label about the image, like my interest is rotten. So functions is the functions about the DynamoDBs, creating an image and then store the result into DynamoDBs. So here is the main functions about everything. The bucket name and keys, the bucket and the keys will obtain the bucket names and the key of the object after the event is occur. Next, call the function about bucket functions to start obtaining the labels. Then extract out the interested labels. Then create out a unique keys. Then store the information to the DynamoDBs. Then after that, I will call out the SNS, then alert the users in the emails about what's going on about the food conditions. Yeah. So now I'm gonna start demo the rotten fruits recognition. So this is the S3 bucket. After the image capture from the cameras, it will upload to it. After the uploads, it will store into DynamoDBs. Here's the details about this is the food IDs, the image names, and the labels about detection. It detects the mold, means it is rotten fruits. Next, in the notifications, you can see that it alert the user through the email. That's all from me.
Hello, my name is Lao Zhenxian and my student ID is 2002629, and now we'll demo the expiry detection module. This is my S3 bucket, which is called expiry item bucket. Inside now I haven't uploaded any item, and then lambda function. In my lambda function I have added the trigger when the S3 bucket have any item uploaded, then it will trigger the lambda functions, and then later it will send the SNS to notify the user. In my lambda function, I have the record detection text in detection text in image functions, which is using the recognition to detect the text from the object in the image. And then I have the detect date function, which is using the text track to detect the date from the text which find from the recognition. And then I have the create message function, which upload the message to the DynamoDB table. And then lambda handler bucket and key will get when the item is uploaded to the S3 bucket, and then detected text will get when the recognition find the text, and then using the detect date function to find the date from the text. And then here is using the SNS to send the message to notify the user. And then now I upload. Okay, now I have successful upload image. And then now the DynamoDB will get the image and the expiry date, and then the also will get the notification from the SNS, which is this message, and show this item is already expired. And then now I upload another image. Okay, now I successfully upload the image, and then now I reload. Okay, the DynamoDB can get the item and the date, and then now we go back to the notification. Yeah, the notification also works well, also showing the expiry date, and then show they still have 209 days left until the expiration. That's all for my demo. Thank you.